and talk about how you can use Code RealTime together with the Model RealTime. And to do that, I will use one of the samples we have on GitHub called Traffic Light Web. So this is basically a traffic light system that consists of a traffic light and pedestrian light. So and also push button and a web server. So the idea is that these traffic lights can be visualized graphically on a web server, and there is also a push button which the user should push when he wants to cross the street, and that should then control what the traffic light and pedestrian lights are set to. So I have built this application, and in the current version, the way it is, you see the push button is not connected to the traffic light. So if I run this application the way it is right now, and then show the web page, we can see here that the traffic light cycles, but when I push this button, nothing happens. We see that there is a message received, but since there is no communication path between push button and traffic light, the traffic light cannot react to that push currently. So now, if you want to do this, you of course need to create a port on push button and another one on traffic light. You have to create a protocol that type those ports and define the event that you want to send on that protocol. And you can of course do that in Model RealTime, like the other protocols I have in this sample here. But now I want instead to do this in Code RealTime and then use that from Model RealTime. So to do that, I have here started Code RealTime in Visual Studio Code. This is the latest version 2.0. And I have also created an empty workspace folder. And I will now start by adding a new art file here, which I will call traffic light control.art. Here I can create my protocol by contassist. So I will call it traffic light control. And I can create an in event called pedestrian. And just for testing, I will also create a copy of this, but with another name and an integer argument. The idea is that I should be able to specify here how many seconds the pedestrian will have for crossing the street, basically. So this is my minimal art file with a protocol with two events. Then to build this into a library, I will create a transformation configuration, which I can call lib. And here I need to specify where do I want this C++ code for this library to be placed. So let's call it lib_target. And I also need to specify the transformation configuration, because I need, of course, to use the same one as I used for my Model RealTime application, which happens to be 64-bit Visual Studio compiler. And this is it. This is all information I need to specify. Now I can build this library from the TC. And you see the code got generated and it gets compiled into a library, which now is located here in the default folder, so lib.lib. So now I want to use this art file and this library from my Model RealTime application. So let's go back to Model RealTime. And first thing I need to do is to make sure that this experimental feature to support art file is enabled. And you will find that here in the experimental features category. And this checkbox will by default not be marked, but I have here already marked it. Next, you need to import your Code RealTime workspace folder into Eclipse. And you can do that by this import wizard, projects from folder or archive. The easiest way to get the location is just to right click here and do copy path. Then you can go here and paste that path and then finish. So here we now have our library TC and we have our art file here. So now I can, just as if this TC was created in Model RealTime, I can go to the prerequisites of my TC and click add, and then I will add this library as a prerequisite. And Then I will also want to see now here how it works. So when I saved this TC, you may have noticed that a new node appeared here, a package import node for the art file. So what happens is that when we add a library TC that comes from Code RealTime, we will add all the art files contained in that TC. And then if you expand it, you will find the same content as you had in Code RealTime. So here we have our traffic light control protocol. We have our two events. And now we can use these exactly as if they were defined in Model RealTime itself. So for example, let's go here and create the port we need. We can select existing element and we can type something in its name. And you can know that something comes from an art file by the first part of the qualified name. Here you have traffic light control.art. Then you know that is the element we want here. And let's call it control. And try to move it down a little bit. Then we need also a port here, typed by the same protocol. And this one we can call traffic light and make it conjugated, of course. And now we should be able to connect these two ports so that we can send the pedestrian event from the push button to the traffic light. And let's save it. Then, of course, we also need to use these new ports. So in the push button, it's referenced in this function here. So I will just uncomment this line, which basically will send the pedestrian event on the traffic light port when we receive the ped button from the web UI. And at the same similar way, I need to use it on this side, on the traffic light. So if I open the state machine diagram here, we see that there are two transitions prepared for handling these events. The first one is for handling the version here, pedestrian, without data. And this will use the default delay of 4 seconds, while the second one will use then the argument that we get with the event. So let's here use pedestrian 2 and uncomment this code. So we'll store the number of seconds in this ped delay variable. We also need down here to handle the possibility that user will click the button while a pedestrian is already crossing the street, and then we should just ignore both these events. So we'll just add them here, and we will not do anything if that happens. So now I've updated my model to use this protocol that I created in Code RealTime, and I can now try to build my application again. And if you look carefully in the link command that was used, you will see here that this library that I created in Code RealTime is now automatically added as a dependency from my executable, just as if it would have been created in Model RealTime. So now let's go back to the command line, and I will now start it for debugging by using this OBS listen flag with 1, 2, 3, 4, 5. So I can run it in the model debugger. Debug as remote real-time application on port 1, 2, 3, 4, 5. And let's resume it, and then we should see the web page. Maybe I should minimize the bit so you can see both at the same time. So now when I push the button now, you see it works. Now it is connected, and this go signal to the pedestrian comes, and it stays there for 4 seconds. That is the default behavior. I can also do the same thing by injecting the event from the debugger here. So if I right click on control and send event, I can pick the pedestrian. And the same thing happened. But now let's try to do the other one. Oops, not sure what that is. Okay, that is something I have not seen before. Okay, that means I cannot unfortunately show that part of the demo, but let's instead disconnect this debugger. And the application is still running, as you can see. And now I will switch instead to Code RealTime, and also minimize the bit so you can see both. So in this version of Code RealTime, we also have a debugger called the Art Debugger, and you can attach to it in the same way as you would have done it in Model RealTime. So just click here, and now you see we are running, attached on 1, 2, 3, 4, 5 on localhost. And here we see the same structure as we would have seen now in Eclipse. So I can now send this event again. And the way it works from this debugger is that you simply put your mouse over the port, this is the control port, and then you click this little arrow here to send events. If we try to send pedestrian 2, you will now get a second pop-up here specifying what argument you should use for this event. So let's put 10 here. And then when we press enter, we now expect this walk signal to be enabled for 10 instead of 4 seconds. And you see it now takes longer before it goes back to stop again. Okay, so this shows how you can now start to use Code RealTime for developing libraries that you use with your Model RealTime application. It also shows that you now can debug them either from Model RealTime or from Code RealTime.